For beginners, you just have Malaysia has one of the best coral reef systems in the world. Okay, Sipadan Island, even Tioman, Redang, beautiful coral reefs. So the good thing about the coral reefs in Malaysia is it's not cold. The waters are warm, so diving is comfortable, enjoyable. Okay. Some places like the Great Barrier Reef, the waters are cold. So even when you go diving, it's not fun at all. Okay. You can see the reefs, but you just feel, I mean, probably for a tropical person, you feel cold. Okay. So coral reefs are located in shallow, warm, clear, and oligotrophic waters. So oligotrophic waters means low nutrients. So basically clean waters. Okay, clean waters. It's the largest geological structure built by organisms, and it has the greatest known diversity in the marine environment. So the area beside Sabah, Indonesia, Sulawesi, and the Mindanao, Philippines, that is actually considered uh, the coral triangle, one of the richest, one of the hotspot in biodiversity. Okay, one of the richest, in terms of biodiversity, one of the richest coral reef sites in the world, the Coral Triangle. So it's beside Sabah, north of Sulawesi, and south of Mindanao. So corals are composed of hermatypic and ahermatypic corals. Okay, so you have hermatypic are reef building corals. So reef building corals are usually the hard corals. Ahermatypic corals do not secrete the calcium carbonate skeleton, so these are considered the soft corals. Okay, so when you go to aquariums in the supermarkets and all that, you'll see that most of them will have soft corals because soft corals are easier to grow. Okay, the hard corals are very difficult to grow, although some says they are able to grow them, but it is very hard uh, to balance the calcium carbonate buffering system in your artificial seawater. So if you use the natural seawater, maybe possible. Unless you stay near to the sea, you do not have access to seawater, natural seawater. So once you use artificial seawater, then it is very hard to grow uh, hard corals. Okay, then that's also the reason why that it is pointless to collect corals. Um, First, it's illegal to collect corals. Uh, if you go to any of the marine parks in Malaysia, once you collect a coral, you're actually breaking the law. Okay, you are not supposed to harvest any corals from marine parks. Okay, so though you hear the case of the Singaporean collecting the hard coral, taking a photograph, Instagramming it, then you get in trouble. Okay, but you can collect corals from outside marine parks, provided you know where the coral reefs are. Okay, because most of the coral reefs that are recorded are in the marine parks. So if you know of a place outside the marine park where there are corals, live natural corals, then it's a good find. Okay, you can harvest from there. But even if you harvest from there, it's pointless because if you cannot grow it, it will die. And once it dies, it will it will rot. Okay, and when it rots, it's very smelly. It's just a rotting flesh. So it is pointless to it is pointless to harvest corals and trying to grow them. Okay, it is better just to go diving and enjoy it when you're diving instead of collecting all these things. Okay, other than other than hermatypic corals and ahermatypic corals, you also have coralline red algae that builds reefs. Okay, so these are very expensive, coralline red algae. So the reefs that they build are actually used, are harvested and to make jewelry. Okay, so these are very expensive nowadays. So Charles Darwin, uh, a proponent of evolution theory, so he observed that there are different types of coral reef systems as he was on his expedition. You have fringing reefs, reefs that grow next to the island. You have barrier reefs, grow further away from the island, and atoll, where you see only the coral reef systems. Okay, so he came up with a hypothesis. He said, fringing reefs are the beginning. Okay, so when you have new form island, okay, the conditions are suitable. You have reefs starting to grow here. Okay, but with time, the island subsides, but the reefs continue growing. Okay, so you get what is known as the barrier reef system. Then with more time, the island sinks, okay, under the seawater level. Then all you see are just the coral reefs. So this becomes the atoll. So when you talk about barrier reef, I'm sure you can give me an example of barrier reef. Okay, the Australian one, the Great Barrier Reef. Okay, so that's the most famous one. Atolls are the ones that you usually see in the Pacific Ocean. Okay. Okay. Although this is just one of the hypotheses, one of the that was proposed to explain this. Different processes can form these reefs as well. So it's just a hypothesis. Okay, to from Charles Darwin to explain the three types of reef systems that you observe. Okay, but different processes can form them as well. Okay, so this explains the fringing reef, young, simplest, the most common kind of reef. Okay, so you see it growing here, still on the island. So these are pictures, examples of the fringing reef. So these are what you most probably will see at Redang Island, Tioman Island. So the barrier coral reef, you have the Great Barrier Reef, largest coral reef in the world. Coral reefs are very high in biodiversity. So that's why it's a valuable ecosystem. So it also barrier reef is because the reefs continue growing here, but as the land subsides, you have the reef forms a barrier. Okay, it actually helps dissipate the wave energy. from outside. Okay. Then sometimes you have seagrasses growing here. Okay, seagrasses in Malaysia, Peninsular Malaysia at least. The famous one will be in Tanjung, in south of Johor. Okay, you have dugong and seagrass, seahorse, dugong, seagrass ecosystem habitat south of Johor, but it's also under threat because of the port development and island development. Okay, so seagrass also very important because seagrass actually filters a lot of nutrients from the land so that it doesn't affect the reefs, coral reefs. So examples of barrier reef. So this is the difference between a fringing and a barrier reef. So atoll is when you see only the circular formed ring shape surrounding central lagoon. So this becomes the lagoon, and this is the atoll. So coral reefs are made up of coral species. It's a community of polyps. It's under the phylum Cnidaria, class Anthozoa. So same phylum as the jellyfish. That's why they have nematocysts. They sometimes they have nematocysts that can sting their prey. Okay, so each polyp can form a colony, a community of polyps. So the polyp then is connected via a connective double layer tissue with digestive systems connected, and they share a common nervous system. Okay, so a coral colony starts when the planula, this is the planktonic coral larva stage, settles on a hard surface, and then once it attaches to a hard surface, and if it's suitable, if the conditions are suitable, it'll start dividing and start forming a colony. Okay, so the key word here is hard surface. That's why you have marine biologists that proposed putting in concrete blocks, putting in old tires last time, in the hope that they will start growing on them. Okay, because they don't grow on sand, they don't grow on silt, they don't grow on sand. They need a hard surface. Then all reef building corals contain the symbiotic zooxanthella. Okay, so these are the Symbiodinium. Okay. They are dinoflagellates. They photosynthesize and they produce carbohydrates and calcium carbonate for the polyps. So this is a symbiosis. The polyps supply metabolic waste for the zooxanthella, and the polyps also supply a habitat, okay, for the zooxanthella. Whereas the zooxanthella photosynthesize, so they produce carbohydrates for the polyps. Because they photosynthesize, they also produce concentrates calcium carbonate for the polyps to be used to build their reefs. So the presence of zooxanthella actually help the corals build faster. Okay, deposit calcium carbonate faster. But you must remember that the average coral accretion means the increase in corals size is only about 3 millimeter per year. That's why you are not advised to pluck or harvest corals, because every coral, it takes millimeters. It grows 3 millimeters only on average per year. Okay, so that means easily with one piece of coral, you're taking up maybe more than 10 years of coral uh, building. Okay, so because they grow so slowly, it is not uh, good to harvest them. Okay, so many corals can survive and grow without eating, as long as the zooxanthellae have enough light. So even if the polyps do not eat, the zooxanthellae can photosynthesize and produce enough nutrients for the polyps. Okay. So this is a cross section of a coral polyp. So you can see the connective tissue between the polyps. This one, each of them polyp. So within the polyp itself, when you have filaments, the tentacles of the polyps, and in the tentacles you'll have your zooxanthella. Okay. The zooxanthella will help photosynthesize and produce energy. Okay, so this is a symbiotic uh, relationship. So they can also feed themselves, the coral polyps. So using these tentacles with stinging cells, they can actually bring food into the mouth, and then this is the stomach, where they'll digest the food via extracellular enzymes. Okay. So this diagram shows the coral life cycle. They have several pathways. First, they can just reproduce asexually by just forming new colonies. Okay, so if you sometimes it breaks, and then if the colony found is on a suitable surface, it can start growing again. Uh, if they also have a sexual cycle here by brooding, which means the eggs are fertilized itself, and then planulae is released. Planulae is the planktonic stage of the coral. If it is not fertilized by a broadcasting system, different corals, some will release the male gametes, some will release the female gametes, eggs and sperms. So once they are released into the water, if they attach, they'll form the zygote, and the zygote will develop into a planula, and the planula, if it will settle, if it finds a suitable surface, it will settle and grow. This release is usually during the full moon. Okay, so there's a cycle, once or twice. I'm not sure how many times per year, but it's usually during the full moon. where the sperm and the eggs are released together and then fertilized, and a new life cycle begins. Okay, so you have both asexual reproduction, they term it as budding or making new clones or colonies. The other is by brooding. This is the sexual reproduction, brooding, internal fertilization, and then you also have your sexual reproduction where you have eggs and sperms. So you can see here the eggs are being released by the coral polyp. Okay, you can see. So you have mass spawning. So usually during the full moon. So these are the coral reefs, example of a coral reef system. So threats to coral reef systems. So if you watch a lot of the National Geographic documentary, you realize that our coral reef system is a threat from global warming, from the aquarium industry, from human activities. So human activities can bring about eutrophication. Okay. For example, you have islands where tourism is the main activity. But when you have more and more people going to the islands, it places a strain on the waste treatment system. So if the waste is not treated properly, you will have nutrients entering the seawater. The nutrients that enter the seawater will lead to an increase in phytoplankton and algae. So this will cause algal bloom or phytoplankton bloom. This bloom reduces transparency, the water becomes less clear. So when the water is less clear, photosynthesis by the zooxanthellae in corals decrease, and then the corals become stressed, hungrier. Okay. Sometimes the algal bloom also smothers the corals, which means it grows on the corals. When it grows on the corals, it suffocates them. It doesn't allow it to perform its normal processes. So eutrophication is a threat to the coral reef ecosystem. Other than eutrophication, when you have a lot of development on the islands, okay, to cater to the tourists, you have buildings. So when you have buildings, uh, inevitably you'll have an increase in suspended solid loading from the construction. So silt and sand, there's an increase in silt and sand onto the going into the sea. So you already know that silt uh, and sand are not suitable surfaces for coral reef systems. It doesn't allow the planulae to attach and doesn't allow the planulae to form new corals. Okay? But not only that, it also blocks and suffocates the corals. It blocks the mouth and then doesn't allow the coral to eat, and also, yeah, doesn't allow the corals to eat. So this is another threat to the coral system. Coral reef fish for the aquarium. So this one is quite a problem in the Philippines, where there is an illegal use of cyanide to stun the coral reef fish, especially after Finding Nemo. After the show, a lot of people suddenly wants to rear clownfish as pets. Okay. So there was a increase in the demand of clownfishes, nice coral reef fishes. So why do they use cyanide? Because if they use nets, you will scar the fish, so it won't look nice. Then people won't buy when they see scars on the skin on the skin of the fish. So you use cyanide to stun the coral reef fishes. Okay, so once it's done, you can just slowly collect the fish. But the problem is, these fishes will not last over 3 to 5 months. Okay, so if you buy these fishes, then it dies after 3 months. If you complain to the seller will say you have no experience rearing these fishes. Okay, so they ask you to buy more. So uh, don't buy this. Don't keep coral reef fishes as pets. Just buy if you want. If you fancy uh, collecting. I mean having an aquarium. Just get the normal fishes. Those are easier to rear also. Okay, because once once there is no demand, there will be less people supplying all these fishes to the aquarium industry. So one more threat is the global warming. So global warming, uh, climate change brings about two threats to coral reef systems. The two immediate threats: one is warming, and one is souring or ocean acidification. So you've seen how ocean acidification re, uh, can increase the stress on coral reefs, because it will be harder for coral reefs to build calcium carbonate skeletons with ocean acidification. Other than ocean acidification, uh, warming will also cause increased stress in the corals. Warming here is anything above 35, 33 degrees Celsius. So in 2015, there was an episode of warming in the Straits of South China Sea, where the water was very warm for long periods of time, about 1 to 2 weeks. And that caused a lot of bleaching, coral bleaching. Coral bleaching when the corals turn white, pale white. Okay. So coral bleaching occurs because the conditions are no longer suitable. So the zooxanthellae is discharged, okay, from the corals. The coral color comes from the zooxanthellae, because zooxanthellae is a photosynthetic organism, so they have chlorophyll pigments, and these chlorophyll pigments have different colors. When the conditions are not suitable, the corals are stressed, they remove the zooxanthellae. So the zooxanthellae, once it's removed, you have coral bleaching. So the good thing about coral bleaching is, if it's if the conditions revert to normal within 2 weeks, the zooxanthellae can come back. Okay, and the host coral can be revived. However, if the conditions are unsuitable, stressful for more than 2 weeks, there is a good chance that the corals will die permanently. Okay, they'll be bleached permanently. So even when you're talking about the bleaching event due to warming, it also depends on how long is the warming duration. If it's too long, more than 2 weeks, so the corals will then be permanently lost. Okay, so these are examples of overfishing. Warming can also be due to El Nino events. Okay, so El Nino events will bring warm water, and this warm water can also cause bleaching. So overfishing with cyanide and explosives will also cause a threat to the coral reefs. Okay, so you have lots of examples of coral reef degradation due to human activities. Okay, any questions?